Now we're going to transition to web, and Wooseok is going to talk about visual completion measurement web.
Hello everyone, my name is Wooseok Jeong. I'm a web performance engineer at Facebook. In this presentation, I'm going to introduce visual completion measurement on website. In the past, traditional web pages used to be simple user interface and static rendering architecture. User interactions were just another page navigations when the user clicks on the link or submit a form. So performance measurement was pretty easy. We could simply capture the web page load latency by waiting for browser's unload event. Then performance metrics could be server response latency or client-side rendering latency. But nowadays, modern websites have become more complex and heavier as a single-page application. They are implemented progressive rendering, which means partial contents are displayed as soon as their data and resource are downloaded to the client. Based on different implementations, some websites are using server-side rendering and some are using client-side rendering. So it turns out web performance measurement has become very challenging and complicated. There are many different ways to measure web performance based on different definition of metrics. Some modern browsers already provide high-level performance APIs for universal metrics, such as time to first byte, first paint, first contentful paint, and largest contentful paint. So you can simply utilize them on your website. They are mostly working very well for generic and simple web pages like mobile website, but sometimes they are not very accurate if page rendering behavior is complex and dynamic in large desktop browsers. Another limitation of generic API is that they are mostly focused on full page loading rather than user interactions because of lack of control on interactive rendering. By this motivation, we want to build a new solution for achieving more accurate, insightful, and reliable measurement. The purpose of visual completion is to measure user-perceived latency of web page loading. With this solution, we can accurately track some user-centric metrics such as first paint, speed index, visually complete, and time to interactive. So we are able to understand how users feel when they are consuming our web content. This will reflect direct correlation between web performance and user engagement with real user monitoring. Not only measuring web page startup performance, visual completion also supports the comprehensive concept of in-app navigations and user interactions. Also, this approach also considers the responsive needs, which means how fast the page can handle user interactions. Let me talk about details of how to instrument. First of all, we have to capture visual progress so that we can calculate accurate metrics. Let's say a user opens a browser and visits our website. Server will progressively flush multiple chunks of payload, and the browser will download various resources like CSS, JavaScript, and images accordingly. Then the browser will display the visual elements through multiple progressive paint. Once there is no pending element to be displayed more, we mark it as visually complete then the visual progress can be instrumented by counting painted pixels over time until visually complete. In a single web page, there can be hundreds of DOM nodes that cannot be instrumented every single element because it might cause excessive overhead and possibly degrade browser's rendering performance. Instead, we can set up a visual change observer that can capture paint timing of discrete component boundary. It represents each progress of the perceived visual change. They can consist of text element or image element under their parent containers. If some images are downloaded separately from its container, then it will be reported as a separated visual change. So we can build a DOM mutation tree data structure that contains the size, position, and timestamp of each rectangles. Let's look at an example. At the first paint, the header section with some images are displayed in the root container. Then, the second flush, the browser displays some elements in left and center position. Through the last data fetch, the browser finished adding all the HTML elements to the document, but it is still waiting for rest of images to be downloaded. Okay, now the browser finally downloaded a few more content images. Then we cut off all the elements outside of the viewport because users cannot see them. Finally, we can determine the timing of visually complete and visually complete without image. Visually complete without image is also another important metric that can be directly affected by server response and client-side performance. There can be different strategies we can optimize visual completion metrics. First of all, we want to reduce the bottleneck and round trips of critical paths. In the meanwhile, for example, we can also try another strategy to reduce the gap of last image latency. For example, we can optimize image size, CDN cache hit rate, or image preloading. Once we generate the element tree and record their sequence timings, we can calculate the painted pixel number for each element by traversing tree structure. If there is overlapped pixel between parent and children, each node can recalculate their own pixels. By producing multiple data structure of visual progress by this algorithm, we can easily derive various useful metrics such as first paint, speed index, and visually complete out of it. As I mentioned in the introduction, visual completion can continuously track all types of interaction in the single-page application. It is very important to have consistent metrics definition between initial load, page transition, and user interaction for better evaluation of our performance. For example, when a user clicks on a profile tab after initial load, JavaScript will fetch more data and download necessary resource to complete page transition, so we can capture visual completion of next page navigation. As long as there is an interaction which makes visual change on the page, we can measure visual completion such as opening a dialog, drop-down, or pop-up menu initiated by mouse click or mouse hover event. Visual completion is a retroactive measurement, which means it has to choose some accurate timestamp among a lot of candidates. It is important to wait enough time until we can collect all the visual change has been captured. But in reality, this is not a simple problem because various edge cases. Basically, we are waiting for the main task to complete, such as base HTML response or AJAX data fetch for the page transition or user interaction. We are utilizing a combination of mutation observer and intersection observer for collecting pent timing of the visual element. But we are only interested in visible contents in the viewport. In the meantime, if there is any visible loading state displayed on the screen, we have to wait until all loading states have disappeared. Then at last, we still need to wait until all the pending images are completely downloaded and displayed on the screen, regardless is lazy loading or preloading. If we miss any slow image, it may report misleading metrics by undercounting the real visual completion. Once there is nothing suspended, eventually we can trigger the visual completion calculator so that it can report the final metrics. Let me talk about how to interpret the data. In the production, there are so many different cases and outliers that can affect statistical aggregation. If we want to understand meaningful performance metrics, we should be able to properly categorize different use cases. Let's think about most ideal case we can expect. If the initial load startup is fast enough and all the elements are ready to handle user interactions on time, we can call it a successful visual completion. Second case is still a successful visual completion for fast navigation, because the user will still feel the initial load was completed on time. But if the website is using server-side rendering architecture with some lazy hydration, or browser is very busy for long task, which delays time to interactive, it is possible that user can click on a particular element, but the event will be queued until the real event handler is ready. This can be some practical trade-off between faster visual completion and delayed interaction by using server-side rendering. If this chance is very low, then it will be a good trade-off, which means we can optimize overall user experience. However, sometimes user can experience that page load is very slow, so they tend to start a new interaction before visually complete is done, or even they can close the entire browser tab. We can distinguish these cases by logging additional tagging as unsuccessful visual completion. These can be caused by some client performance issue or network problems. So most cases, performance numbers will be very noisy. So it will be better to track just percentage of unsuccessful cases instead of latency metrics aggregation. Based on visual completion measurement and data logging, we can define multiple performance goals to improve user experience. It's obvious we want our website to be performant, such as faster visually complete and lower speed index score. But We also need to reduce percentage of bad experiences like unsuccessful completion and delayed interaction. At Facebook, we are rebuilding new Facebook.com that has the primary goal of fast startup and responsive interactions. Visual completion is one of key performance metrics to make sure our website is serving delightful user experiences. To achieve this performance goal, we also built various performance tools that can support insightful data analysis. When performance regression alerts have been reported, we should provide powerful investigation solutions as well. In the last slide, you can find some definition for supplemental submetrics and tagging. These will be useful when we want to find some consistent patterns in data segmentation. Flexible data query will help us find optimization opportunities or investigating root cause of performance regression easily. So currently, visual completion is still under development, but I hope we can share more technical details very soon. Thank you.
Thank you so much, Wooseok. It was a great talk, so I hope that everyone enjoyed it. Unfortunately, again, we don't have time because we're a little bit over time for this talk.